Greetings and welcome. This session we are going to see a procedure to solve a numerical to calculate shear stress at the pipe wall, total friction drag and power required to maintain flow in a pipe line. Let us see the statement of the numerical. A lubricating oil of viscosity of 10 points and specific gravity 0.8 is pumped through a 50 mm diameter pipe. If the pressure drop per meter length of pipe is 20 kN per meter square, calculate discharge of oil in liter per second, shear stress at the pipe wall, total friction drag and power required per 50 meter length of pipe to maintain flow. Let us see the data required for the calculation, which is mentioned over here. Dynamic viscosity of oil, that is mu, value is given in poise. We need that value in SI unit, so we convert poise to Newton second per meter square by dividing this value with 10. So we find this dynamic viscosity in Newton second per meter square. Specific gravity is given, that is written here. Diameter of the pipe is in given millimeter, that we convert into meter. For the calculation purpose, we need in the formulae radius, so that is why we calculate the radius also. So radius is half of the diameter, so half of the diameter in mm, and further that converted into meter. Pressure drop per meter, that is pressure gradient we say. So pressure gradient is a negative because we have seen in a theory that pressure decreases in the direction of flow. So value del by p by del by x with a negative sign, that is given in the numerical statement 20 kN per meter square, that we convert into Newton per meter square by multiplying it with 10 raised to 3. Then to calculate friction drag and power for 50 meter pipe, that is the length of the pipe is here 50 meter. Now using this data, first of all we will calculate the first parameter asked, that is discharge of oil in liter per second. Now we know that for incompressible fluid, with the help of continuity equation we use the discharge formula, that is product of area into velocity. So here we take Q is equal to area into average velocity. Now as per the data given in the statement, oil flow through pipe, this is a diagram. Here the radius capital R is shown. So cross-sectional area of the pipe is circular. So that is why for circular cross-section area, a formula is pi into capital R square. Then from the theory part of this internal flow, average velocity formula we use, that is U average is equal to 1 upon 8 mu, means dynamic viscosity, multiplied by pressure gradient into capital R square. So now we substitute the expression for area and average velocity in this formula. Thus we get discharge Q is equal to A means pi R square, U average means 1 upon 8 mu into pressure gradient into R square. Here this R square multiplication, we get R raised to 4. So we find the formula Q is equal to pi R raised to 4 divided by 8 mu into pressure gradient. In this formula we put the value which are given in the statement. So Q is equal to pi into value of radius in meter raised to 4 divided by 8 into value of dynamic viscosity mu multiplied by value of pressure gradient given that is in Newton per meter square. So after doing this calculation, we find the value of discharge in meter cube per second. But in the numerical statement, it is expected to mention the discharge value in liter per second. So further, we convert this meter cube per second value to liter per second by multiplying this with 10 raised to 3. So this is what discharge of oil in liter per second. The second parameter asked is shear stress at the pipe wall. Now here also from the theory, means from the derivation part of the internal flow, that is a flow of a liquid in a circular pipe. In case of laminar flow, we have relation for maximum shear stress which occurs at the pipe wall, that is capital R by 2, means radius by 2 into pressure gradient. So we put the value which are given, that is radius in a meter and the value of pressure gradient in Newton per meter square. Doing the calculation, we get the shear stress at pipe wall in Newton per meter square. Now the next, that is third parameter asked, is a total friction drag for 50 meter length of pipe. So let us use a diagram for the clarification of the use of data. So here this is a pipe with a diameter capital D and a length with L. Now here first of all we have to calculate surface area, because surface area is used in calculation of shear stress. So surface area for circular pipe means this lateral area is what? Pi d, that is the circumference of this pipe into length capital L. So pi d L. We know that shear stress is a ratio of shear force, we call it as friction drag divided by this surface area. So we arrange this equation in the terms of friction drag which we need to calculate. So we use the notation for friction drag, capital FD is equal to product of shear stress into surface area. Further, we place pi dl for the surface area. So we find the formula FD is equal to tau into pi dl. So already we have calculated value of tau that we put here, multiplied by pi, value of d in meter and value of L in meter, which are given in the statement. After the calculation, we find the total friction drag in a Newton. This we can mention in kilonewton also. So this was a third answer. The fourth parameter is to be calculated is power required for 50 meter length of a pipe to maintain flow. Now we know that power is a product of pressure into discharge. Then next we are given pressure gradient along the direction of motion per unit meter. So per meter, that is minus dA by P by dA by X, and we have to calculate that for length 50 meter. So first of all, for the pressure we will modify the formula, that is pressure gradient multiplied by length. Value of pressure gradient in a Newton per meter square, value of length in a meter. Doing the calculation, we get pressure for 50 meter length of pipe. Then this we use here in the calculation of power. So power is equal to value of pressure and value of discharge in meter cube per second, which is calculated in previous slides. So after the calculation, we get the answer for power in watt. We can mention this power in kilowatt also. So this is what power required for 50 meter length of pipe. So this was the procedure to calculate the discharge then total friction drag, shear stress at pipe wall, and power required to maintain the flow in a pipe for the oil flow, that is a laminar flow in a circular pipe. Let us meet in the next video session. Thank you.